So hi, this is Spyros from UCLA, and I'll be talking about the real-time data retrieval protocol. So first of all, this protocol has to do. There has been a long-standing question how we can fetch the latest generated data, real-time data, in a network that features caching. As Peter said before, we actually have segment numbers instead of application-level timestamps. And we need to know the exact name, the exact name of the data in order to pipeline interest to fetch multiple data segments and potentially also the name of the data that hasn't been generated yet. So this is a rather simplified example, an extreme as well, but I would just to illustrate the problem. So in this case, we have two participants. You can assume that, you can think that, these participants are having like a video conferencing call, for example, using NDN RTC. So we have the data producer on the one end. So the first participant will join and will send an interest for some real-time data. So this interest will go through the network, will be forwarded through the network, reach the data producer, and the data producer will send the data back with segment number of the latest data, which is number 5. This data packet will be cached through the network. So after a minute that the participant number 2 might join, will express the same interest for the real-time data. However, it will fetch the cached copy from a minute ago, indicating that the latest generated data actually has a sequence number 5. So what we try to do is we try to retrieve the latest data through by making use of protocol and the NDN protocol features. So we have the producers that generate metadata for real-time sessions. So this metadata determines for how long they can stay. So the producers determines for how long the metadata can stay fresh at its content store through the freshness period in the data packet. This metadata carries the name of the latest data, as well as optionally the latest generated segment itself. The consumers will send an interest for fresh metadata using the must be fresh element in the interest data packet. This interest will bypass non-fresh metadata in the network caches, and in this way, the consumer will be able to learn the exact name of the latest generated data. Well, in the sense that this data was generated approximately half an RTT before. So let's see an example. We tried to apply that. Our first use case was NDN RTC streaming. So you can see on the left the consumer that is sending an interest for the metadata for a session, for an NDN RTC session. So this interest will reach the producer, and the producer will send back its metadata. So as you can see, the metadata in the meta info section, it has a relatively small freshness period, and I will get into the trade-offs of setting the value of this freshness period. And the content actually has the name of the latest delta frame and the first segment of the latest keyframe. In this way, the name of the latest delta frame says that the latest delta frame is number 92. So in this way, the consumer can pipeline interest to fetch delta frames 93, 94, and so on and so forth. And for the keyframe, this is keyframe number 3. So the consumer can pipeline interest to fetch the next keyframes, 4, 5, and etc. However, there are some considerations about the freshness period. So specifically, the freshness period is a per hop relative metric. That means that metadata may stay fresh for a longer time in terms of absolute time, further away from the producer due to processing and propagation delays. So there is a trade-off in the sense that we want the freshness period short enough so that we can avoid fetching stale metadata further away from the producer from some in-network cache, but long enough so that we can protect the producer from consumers that might try to abuse this mechanism. And if you would like to learn more, we published a paper on describing this protocol about a month ago, and also the NDN RTC paper published by Peter and Jeff 2 years ago, well, 3 years ago at the ICN conference. Thanks.
What application?
Yeah.
I have a problem to use the
Yeah, so we use the
must be fresh option.
Yeah, so we use the must be fresh option because we want to fetch only fresh metadata. So we would like to bypass stale metadata in some network cache. Yeah, so can we use the can be prefix option because if you see this data packet will have a longer name. So that's why we're using that to indicate that the data packet can have a longer name.
For the components, I think can be prefix is the right?
I mean, so you're worried again for exact matching versus prefix matching, or in case that in case there is cached metadata in some router, then automatically it will fetch the data with the longest. If there is cache metadata that's fresh, it will fetch the metadata with the latest version of it. We haven't evaluated how much burden that can be, but even that, I think that the case that you will be able to fetch cache metadata is relatively low, given that, as you can see here, the freshness period is we expect it to be relatively low, and so 10 milliseconds. Given that if you join a conference call, the participants will join over a few minutes. So I think that the chance that this will happen is relatively low.
What are the key differences between the protocol in the 3-year-old paper and this protocol?
Sure. So 3 years before, we were using the exclude selector. The exclude selector, however, can only select, in the case that you have multiple cache data packets that would satisfy an interest, it can specify which one you would like to retrieve. This is new in the sense that we try to entirely bypass. So far, we weren't making use of freshness period or any other features of the NDN protocol spec to try to bypass stale versions of data in some network cache and try actually to fetch the metadata that indicates which is the latest real-time data that has been generated. So before we weren't doing this, let's call it metadata exchange.
I want to add to that.
Sure.
In a previous protocol, since we didn't rely on the freshness, we had to exhaust the network, exhaust the cache from the network, and there was a chasing approach where we increase the interest rate artificially. If even your stream is 30 frames per second, we issue interest, say 60 times a second to exhaust the cache and wait till the latest data start to arrive at the production. So now this one is gone. It was not very reliable.
So now, you can say the much less interruptions.
So we see the bootstrapping is much shorter. Previously it took from 500 to 1,500 milliseconds. Right now the bootstrapping is half RTT, which is
it's almost it's almost optimal. Half RTT.
But after bootstrapping, the video is more stable, became more stable, or it doesn't matter?
You can recover more quickly too.
Yeah.
Because you don't have to re-enter chasing things. You give up a little bit of the sort of lack of dependence on the publisher providing the kind of data. So there are even more assumptions in this approach, but ultimately